Good morning, it's parabola time. Look at the directions. Graph the parabola. Well, this form's general form. We need to get it into vertex form or standard form when we talk about conics. Notice that it's x squared with the x. These are the two that need to form a perfect square trinomial, which means we have to get y over to the other side. We're going to leave 20 on this side. It's a little different with parabolas. Let's get started here. I need to change the form, moving y over to the other side, putting x's together to make a perfect square trinomial, and remembering to balance the equation over here with the constant. So I rewrite it, x squared plus 10x plus this blank, make a perfect square trinomial. And I still have plus a 20, and I have to remember to subtract the number that makes the perfect square trinomial here. Whatever I add in, I have to subtract this time because I'm on the same side of the equation. And then this is going to be equal to y because I had to move over that y to the other side. So what will make a perfect square trinomial? Half of 10 is 5, and when we square it, we get 25. So 25 makes a perfect square trinomial. 25 times 1, there's a 1 here. 1 times 25 balances the equation, which is just 25. Now, just like in our other conic sections, we need to factor the trinomial, collect like terms. I'm going to have my y equals on the left side this time just because it looks prettier. And my equation now has become y equals x plus 5 quantity squared minus 5. That's standard form, vertex form also. Remember the a value is 1, and my vertex is at -5, -5. So let's start writing all that good stuff out to be able to graph it. We start, once again, with the vertex being at -5, -5. And I put that on the graph. So I go to -5, -5. Let's see how well this works with a stylus. We're out right there. Good. Next is your axis of symmetry. Remember, it's a line. It's a line that's going to be right through the vertex. Vertical line. Vertical lines, x equals, what does x equal in that vertex? -5. Also, how does it open? Two things to consider. When it opens, it's y equals, so it's vertical, up or down, and a is +1, so it must be opening up. This opens upward. Next, we have that formula I said you have to remember. Put a little star. This is how we get the rest of this graph. I take 1 over a. If a is 1, the reciprocal of 1 is 1. Divide it by 4, just always dividing by 4. I get 1/4. I'm going to need to move 1/4 upward to find the focus, which is next. I need to get my focus. Oops. Let's move this up. Now, if I move 1/4 upward, again, that finds my focus. Focus being a point. 1/4 upward, that's tiny. I don't know if I can even get that on the graph here. 1/4 upward for the focus. A little more than 1/4, but you get the gist. Upward from the vertex puts the focus still x-coordinate -5, but up 1/4 from -5 on the y gives us a coordinate of -4 3/4. The directrix, the opposite direction, we have to take 1/4 down now from the vertex, 1/4 downward, and it's a line. If you move 1/4 downward, let's see how well this works out. 1/4 downward, you get over down below that vertex. The directrix is a line, so it's an equation. the directrix line horizontal is y equals a quarter down from the y coordinate on the vertex. A quarter downward gives us an equation, -5 and 1/4, y equals. And last is the rest of the graph. How far apart are the focus and directrix? How far apart are the focus and directrix? If I moved a quarter up for the focus and a quarter down for the directrix, a quarter and a quarter makes a half. They're a half a unit apart, even though it doesn't look like that on this graph. So to make the rest of the parabola, I take half a unit from the focus, go to the right, go a half a unit to the left from the focus. So if I have a half a unit in both directions, that means my latus rectum is 1 total unit long. And through those points, you can now draw your parabola and pretend it's a U shape and not this ugly looking V. And there we go.